All right, in the world of electricity, there are three little words that cause a whole lot of confusion: earthing, grounding, and neutral. Mixing these up isn't just a simple mistake, it can actually be pretty dangerous. So today, we're going to make the difference crystal clear. So, what's the real difference here? Are they just different names for the same thing? If you've ever had that moment of hesitation trying to answer that, you're definitely in the right place. Let's dive in and get this sorted out.
And look, this isn't just about getting the terms right for a test. Our source material puts it really bluntly with this quote: getting these wrong can lead to some major problems out in the real world. Why? Because one saves your life, one protects the equipment, and one, well, it just makes the whole thing work.
Okay, let's start with the most important one, the one that's all about you and me. The first member of our Trinity is earthing, and its entire job, its whole reason for being, is human safety. Now, the key phrase here, the one you really need to lock onto, is non-current carrying parts. We're talking about the metal casing of an appliance, the body of a motor, basically any metal part that you could touch that is absolutely not supposed to have electricity flowing through it. So why connect that metal casing to the earth? Well, let's imagine a wire inside comes loose and touches that metal body. Suddenly, that whole surface is live. If you touch it, the electricity is going to try to go through you to get to the ground. Earthing gives that rogue current a much easier path, like an electrical expressway, to travel safely into the earth. That trips a breaker and prevents you from getting a fatal shock. Think of it as a personal bodyguard. Okay, let's move on. We're going to shift our focus now from protecting people to protecting the equipment itself. And this is where we get into the world of grounding. And right here, you can see the fundamental difference. Unlike earthing, where we connected the parts that shouldn't have current, grounding is where we intentionally connect a part of the system that is supposed to carry current, like the neutral point on a transformer, and connect it directly to the earth. So, why in the world would we do that? Well, grounding acts like a giant shock absorber for the entire electrical system. It gives everything a stable reference point, a solid 0 volts. This is what protects all your expensive equipment from getting totally fried by massive voltage spikes from something like a lightning strike. So if earthing is a bodyguard for people, grounding is the bodyguard for the machinery. So we've protected people and we've protected the system, but how does anything even turn on? To get that answer, we need our third and final element, the neutral wire. The definition here sounds really simple, but it is absolutely critical. Just think of electricity as needing to make a round trip. For it to do any work, it needs a complete loop, a path from the source, through your light bulb, and then a clear path all the way back. And that's the neutral's one and only job. It's the highway back home for the current. Without that neutral wire, the circuit's broken, the loop's incomplete. Your lights won't turn on, nothing works. It's not about safety or protection, it's all about making the system function. Okay, so we've looked at each one on its own. Now let's put them all side by side to really hammer home the difference. This is where it all clicks into place. Just look at this breakdown. It couldn't be any clearer, right? For earthing, the main purpose is human safety. For grounding, it's all about system stability. And for the neutral, it's simply there to provide the return path. 3 different components, 3 totally different jobs. If you remember nothing else from all this, just remember this one sentence. Earthing protects life, grounding protects equipment, and neutral makes the whole thing work. It's as simple as that. And getting this right is just non-negotiable. Like our source material warns, confusing these roles in the field can lead to some truly dangerous mistakes. It really drives home why this isn't just some academic exercise. It's essential knowledge for anyone who works around electricity. And that really brings us to our final thought. Now that you know the difference, the question isn't just about theory anymore. It's about practice. It's about safety and function out there in the real world. So take a second and ask yourself, are your connections correct? Thanks for joining me for this explainer.